Hey all you cool cats and kittens, we're going to be doing some problems talking about wavelength, frequency, and wave velocity. Before we do that, I want to take a quick minute to make sure we're all on the same page about what frequency and period of a wave are. So I'm going to have us define frequency as, just because it has the word frequent in it, how frequently a wave occurs. And we're going to measure it in hertz, which is Hz, hertz. But what that really just is, and this is also how we calculate it, is the number of waves over the amount of time. So an example of this is if I said, oh, 3 waves pass by, and it takes 2 seconds. All we would do is we would say, well, the frequency, the f, I'll put f there to remind us for frequency, is 3 waves over 2 seconds. Put that in our calculator, we get 1.5, and then the units are hertz. So that's frequency. It's how frequently a wave is occurring. Now, a very similar concept is called period. The period of a wave is how much time a single wave takes. And it's measured, like most things for time, in seconds. So we can go back to the previous example. If I said 3 waves pass by in 2 seconds, and instead of saying, well, 3 waves over 2 seconds is 1.5 waves per second, or hertz, that's the frequency, I could flip it around. I could say, well, the total amount of time is 2 seconds over 3 waves. So each wave is taking 0.667, repeating seconds, and that is the period. And we use t instead of p. We use t for period because it's related to time. We use capital T instead of lowercase t because we usually use lowercase t for like amount of time. We use capital T for period. Now, something that I know some of you have seen this equation, the way they relate, and you can even see in the equations, if frequency is waves over seconds and period is seconds over waves, they are exactly related to each other inversely. So frequency is equal to 1 over the period, and period is equal to 1 over the frequency. So what this means is if I were to ever give you the period, I'd expect you to be able to find the frequency just by doing 1 over, So from these like quote-unquote notes, what you need to know how to calculate frequency and period. So you need to know this equation. You need to know this equation, how it's just the inverse. And you need to know how they relate to each other and that they're the inverse. And if you know those 2 or 3 things, you're probably on a good spot for frequency and wavelength. So now I want to use this on one of the sample problems. So the practice problems from your packet, I'm going to look at number 5. And number 5 says you're sitting on the dock of the bay watching the tide roll away. You count 4 waves in 14 seconds. So what is the frequency? So first for frequency, I'm going to go, okay, well that's number of waves over the amount of time. So according to the problem, there are 4 waves in 14 seconds. And I put 4 over 14 in my calculator, and I get 0.29. And then remember, the units for this are hertz. Hertz are a fancy unit that just means per second. So it's like waves per second. So the frequency is 0.29 hertz, 0.29 waves every second. Letter B, what is the period? So there are 2 ways we could do this, and I'll show you both. The first way is we could say, well, it's the amount of time over the number of waves. And I could say, okay, that's 14 seconds over 4 waves. And I would get 3.5 seconds. Or what you can do, and this is equally valid, equally legal, once we find the frequency, you can say, well, I know period is just the inverse of frequency. So I'll put 1 over 0.29. I put that in my calculator, and I also get 3.5 seconds. So whichever way you go about it, they both are valid, and in some cases, you'll only have the info to do this way, or only have the info to do this way, but in this case, we could do both. You'll get the period. And then see what is the velocity if you eyeball it and see that the wavelength is 3.8. So for this, we need to have the wave equation, which I believe we should have in our notes already, but in case we don't, I'll rewrite it. And that is that velocity is equal to frequency times wavelength. So V is velocity, F is frequency, what we just talked about, and this lambda, this upside down Y looking shape, is wavelength. So in this problem, this is actually really simple because we already calculated the frequency, we know that, and the problem tells us the wavelength is 3.8 meters. So I just plug that in. V equals 0.29 hertz times 3.8 meters, and I get 1.1 meters per second. And that relates velocity, frequency, and wavelength. So this is another equation you should definitely have in your notes somewhere. All right, hope this helps you solve the practice problems and get on with yearly. Good luck.